problems based on sum to n terms of geometric progression. So here we are going to perform problems which are based upon sum to n terms of geometric progression. So here symbolically it can be denoted by means of geometrical progression by means of GP. So here this is under problems we are going to perform under part 1 under the advanced level. So here the gen form of the geometric progression is of AR square, AR cube. Similarly and so on, the nth term will be of AR to the power of n minus 1. Then sum to n terms will be denoted by means of S of n. So here S of n can be given by means of A into 1 minus r to the power of n divided by 1 minus r when r is less than 1, and similarly S of n can be given by means of A into r to the power of n minus 1 by r minus 1 when r is greater than 1. So here we are going to perform the problem under the same. So here the problem is of, in a GP, that is geometric progression, with A equals to, that is the first term, equals to 1, and r, the common ratio, is equals to root 3. So here we have to find out the sum to 14 terms. We have to find out the sum to 14 terms of the geometric progression. When A value, the first term is of 1 and the ratio, common ratio throughout the sequence of the geometric progression is of root 3, then we have to add up all the 14 terms from the first term, that is A. So here what will be the sum of that 14 terms of that particular GP is the question. So now the solution starts. As per the problem, so in a geometric progression, A, that is the first term, A is equals to the first term of the geometric progression is given by means of 1, and at the same time, so here R, the common ratio, is given by means of root 3. So here this is the A is the first term of the GP, and whereas R, the common ratio. But here the R value is given as root 3, but its value is of 1.732 approximately, that is nearly. So now in the next logical step, so based upon this R, so that is equals to 1.732, which is nearly, it is greater than 1. It is 1.732, but it is of only 1. So 1.732 is greater than 1. So here hence we can write. So therefore, so R value is greater than 1. When R is greater than 1, then sum of n terms of the geometric progression when the condition, that is R is greater than 1, is given by means of, so here since it is sum, we can denote it by S, capital S, of n terms. So we can write it as, so sum of n terms is equals to, since R is greater, so here we have to write as the formula as A into, so R is greater, so here we can write as R to the power of n. So here this is greater minus the least is of 1. So R is greater, the 1 is lesser, so greater minus least. So here R to the power of n minus 1 overall divided by, so here greater minus 1, that is R minus 1 is the formula. So here when R is, the condition is R is greater than 1. We can apply this formula if and only if this ratio, that is the common ratio, is greater than 1. But here as per the problem, or according to problem, we have to find out the sum to 14 terms. So here sum to 14 terms of GP is given by, so here in order to find out the sum, so here we will be denoting the sum by means of S. Since it is of n terms, we wrote it as n, that is Sn. Here we are going to find out the sum of these 14 terms, so we can note it by means of S, that is sum of the 14 terms. S14 indicates the sum of 14 terms. Then now, so here S of 14 is equals to, so here let us compare this S of 14 with this S of n. The formula equals to A into R power n minus 1 divided by R minus 1. So now, so here n must be replaced by means of 14. So here at n is equals to 14. When we replace n by means of 14, say in this formula, then A equals to A value. So here A is of A. As per the problem, the first term is of, so here A value is of 1. So A value is of 1. So here we can replace A, the first term, by means of 1. A value 1 into R to the power of n. So R value, the ratio, so here common ratio is of R is equals to 1.732. It is of root 3. So here root 3 minus 1 overall divided by R value, again it is of, but so here R is replaced by means of root 3, but R to the power of n, so here whole to the power of n value, so here n value is of 14 overall divided by R minus 1, so here R is of root 3, which is the value of 1.732, so minus 1, instead of 1.732 I wrote it as root 3. Then now the next logical step will be of, so 1 into this bracket will be of same bracket, so here within this square brackets there is of root 3, so here root 3, so I want to write root 3, so here based upon this formula, that is, so here root A can be written as A to the power of, when square root is cancelled over here on the left hand side, we will write the exponent as A to the power of 1 by 2. When it is of nth root of A, we would have written here A to the power of 1 by n. So here when square root is cancelled, we have to write as A raised to the power of 1 by 2. Based upon this reason, so I want to write this logical step as, so based upon this reason, the logical step will be of root 3 can be written as 3 raised to the power of, so here root 3, when root is cancelled, so I write the exponent as 1 by 2, but whole to the power of 14 again, so here flower brackets whole to the power of 14 minus 1 overall divided by root 3 minus 1. Then now the next logical step will be of, it is in the form of A power m whole power n. So A power m whole power n can be written as A power m into n, bracket indicates into, as per that identity, so here A power m into A power m whole power n as A power m into n. So here the next logical step will be of, so that implies S14 equals to S of 14 is equals to, within the square bracket, so 3 to the power of, say here m into n, half into 14 minus 1 overall divided by root 3 minus 1, half into 14 minus 1 overall divided by root 3 minus 1. So here I have utilized the identity, that is A power m whole power n is equals to A power m into n. So here based upon this identity I wrote this logical step. Then now the next logical step will be of, that implies that S14 will be equals to, so here the numerator is of 14 and the denominator is of 2, so here 2 1s in the denominator and 2 7s in the numerator, so here, so in this manner we will be getting the next logical step as 3 raised to the power of 1 into 7 as 7 minus 1 written as it is within the square brackets by divided by root 3 minus 1. Then now the next logical step will be of, since the denominator is having a surd, that is root 3, so here root 3 minus 1, so here we know that, so A minus B's conjugate or the rationalizing factor will be of A plus B. So here root 3 minus 1's rationalizing factor will be of root 3 plus 1. So here multiplying both numerator and denominator by means of its rationalizing factor or the conjugate. So its conjugate is of root 3 minus 1. So you write it as plus 1. It is in the form of A minus B. So here conjugate will be A plus B. So here when we have multiplied the denominator here by means of root 3 plus 1, at the same time we have to multiply the numerator also by the same, that is root 3 plus 1 itself divided by root 3 plus 1. So here I got this step. So here by means of, by multiplying n and d's, so here n stands for numerator and as well as denominator, by means of, by conjugate of root 3 minus 1, that is root 3 plus 1. Then now the next logical step will be of, so that implies S14 is given by means of, that equals to, within bracket when 3 is multiplied 7 number of times, that is 3 into 3 into 3. So here 3 to the power of 7 can be written as base must be repeatedly multiplied 7 number of times, that is exponent number of times, into 3 3 times, 4th time, 5th time, 6th time and 7th time. So that equals to, when we multiply these all, so we will be getting it as 2187. So here instead of, that is 3 power 7, we can write it as 2187. So based upon this reason, so here I want to write this logical step as 3 power 7 can be written as 2187 minus 1 as it is, overall divided by, so here into, so here one more factor as root 3 plus 1, overall divided by, it is in the form of now, so here a is of root 3 and b is of 1. When we assumed root 3 as a, so here a, root 3 will be assumed again as a, then 1 is of b, then 1 will be of b. Then now when we see this special product, it is in the form of the special product a minus b into a plus b. So we know that a minus b into a plus b is equals to a square minus b square. So here a square, that is root 3 whole square minus b square, that is 1 whole square. I got this logical step. So here by the reason, that is a plus b into a minus b is equals to a square minus b square. So here based upon this reason, so I wrote the denominator as root 3 whole square minus 1 whole square. So here I have utilized these two conditions, these two reasons in order to write the numerator and as well as the denominator. The now, so here square and the root will be gets cancelled in the denominator. So the next logical step will be of, that implies S14 is given by means of, that equals to 2187 minus 1 is of 2186 multiplied with root 3 plus 1 overall divided by, so here 3 is left over in the denominator, minus 1 square is of 1. Then now, so in the next logical step, so we will be getting it as S14 is equals to 2186 14th term. So sum of the 14 terms is equals to 2186 into root 3 plus 1 overall divided by 2 by further simplifications. So here 2 ones in the denominator and the numerator. So here 2 ones is of 2, then now here 1. So here 2 ones is of 2, but it is less than 2. So 0 times is possible, 2 zeros are 0. Then now here 1. So attached to this 8. So here we have to see the 2 digits, that is 18. So 2 nines is of 18 now. So 2 threes is of 6. So in this manner I got 1093 multiplied with root 3 plus 1. So the next logical step will be of, that implies S of 14, that is sum of 14 terms, equals to 1093 multiplied with root 3 plus 1 divided by 1, nothing but again 1093 into root 3 plus 1 is the sum of 14 terms. So here we can replace this root 3 by means of 1.732 again. So when root 3 is replaced by means of 1.732, then plus 1 it will be of 2.732. So here we have to multiply 2.732 with 1093, then we are getting the value of So now I want to so that implies S of 14 is equals to is equals to 1093. So here so root 3 is replaced by means of 1.732 then plus 1. So here the next logical step will be of implies S of 14 is to 1093 so here into, so here 1 plus 1 is of 2, or in other words, so 1.732 plus 1, that is 1.000. So here 1 plus 2 as it is, then now 3 plus 0 is of 3, then now here 7 plus 0 is of 7, 1 plus 1 is of 2. So we can write it as 1.732 plus 1 is of 2.732. So here when we multiply 1093 into, so here 2.732, then therefore the next logical step, that is S of 14, sum of 14 terms will be of 2986.076. So here we can correct it to 2 places of decimals. So here the third place is of 6, that is greater than 4. So we can struck off and add 1 to the preceding digit. So here therefore we will be getting S of 14, that is sum of 14 terms is equals to 2986.07. So in this manner we got the sum of 14 terms of the geometric progression is of 2986.07.